Alright, so anytime that you have one of these mole ratios questions, you can follow these 4 steps to get to the right answer. So first you have to find the equation that the problem is giving you. It all starts with a chemical equation. So if it says 4.5 moles of water, okay, well I know that's H2O, are decomposed. This is a type of reaction where you have a compound, A and B. When the reaction happens, you separate into A plus B. That is a decomposition reaction, so decompose, that's what that means. How many moles of oxygen? I know that oxygen is diatomic, so this is going to be O2, will be produced, round to the nearest 100. Because I know that water is H2O and a decomposition reaction takes a compound and splits it up into individual parts, I'm going to have oxygen and I am going to also have hydrogen. Hydrogen is also a diatomic molecule. We also saw this fraction. We've been working with it like this whole time with all the examples that I've been showing you. So you've seen this before. Okay, so I found my equation. 1 is checked off. Number 2, I have to balance my equation. So on this side, I have hydrogen and I have oxygen. On this side, I also have hydrogen and I also have oxygen. I have 2 hydrogens here and 1 oxygen on this side, on the reactant side. On my product side, I have 2 oxygens and I have 2 hydrogens. So obviously it's not balanced because my oxygen numbers do not match up, so I have to go in there and do some stuff to balance it out. So if I multiply my oxygen on the reactant side by 2, that means I have to put this 2 coefficient in front of my oxygen. So that matches my oxygens, but now I also have this coefficient multiplying this subscript by 2. So now I have 4 hydrogens on this side and only 2 on this side. So I can go and multiply this side also by 2 to give me 4, and then they would be matched. But that means I have to put this coefficient in front of my hydrogens. And now everything is matched. So my balanced reaction is 2 H2O, 1 O2, remember there's nothing, it means 1, plus 2 H2. So I balance my reaction. Now I have to find the ratio between what they want me to compare. So in the question, they gave me 4.5 moles of water. How many moles of oxygen? So they gave me water and they want to know oxygen. They gave me water and they want to know oxygen. The ratio between water and, I circled hydrogen, whoops, oxygen. So they gave me water and they want to know oxygen. The ratio between water and oxygen is determined by the coefficients. So there is a 2 water, 2, 1 oxygen. So the ratio between water and oxygen is 2 to 1. There are 2 waters for every 1 oxygen. This is my ratio, and I found that again after I balanced my equation and looked at the coefficients. Lastly, I need to set up my fraction. So what this means is I'm going to put my water on the top. Move it over right here a little bit. I'm going to put my water on the top and my oxygen at the bottom. So I know that for every 2 waters, I have 1 oxygen. I can set this equal to a ratio of 4.5 moles of water is equal to how many moles of oxygen. Like that is what I'm trying to find. So I can set up this fraction to help me solve for my unknown. So I can do my butterfly multiplication method where I can go, well, I can multiply this. So 1 times 4.5 is 4.5 equal to, and then I can multiply my other part of the butterfly, 2 times something. So 2 times x. I'm going to call this x. So now I can just solve for x, divide both sides by 2, and 4.5 divided by 2, if you can do this on your head, super proud. So 4.5 divided by 2 is 2.25 is equal to x. And the question tells me to round to the nearest tenth. That means the first decimal place. So x is actually equal to 2.3. So there, for every 4.5 moles of water, there are 2.3 moles of oxygen. And that is how you solved it. So you set up your equation, you balance it out, use the coefficients to find the ratio of whatever they're asking you, and then you set up a ratio equation where you're comparing both ratios and just solving for the missing piece. And that's it.